Welcome to the channel RKL Learner, and here I am going to explain you a system of these boxes fitted with a single pulley. When such kind of one system moves under different circumstances, what is going to happen with their relative motion? Okay, so today we are learning some relative motion regarding this picture. So first I explain you taking uniform motion. Okay, so uniform motion. A and B are moving up and down. If I assume B is coming down with a velocity Vb with respect to ground, okay, so this Vb is measured with respect to ground. Okay, ground is a fixed frame of reference. Meantime, this box is moving up with a velocity Va, that is also with a reference to, right, that Va is also with reference to ground. Right, so one more thing I have to tell you, all directions which are considered upside are taken positive and all directions directed downward are taken negative. This is the most important conclusion that we must learn about sign. Okay, so now I am going to tell you what happens with the relative motion. You know, if A moving up with velocity Va and this is moving down with velocity Vb, so since this is a fixed system, right, it is a fixed system, both of them having same velocities. Here what is going to happen, since it is a fixed system and it rises, right, it will come down. So for that reason the terms Va and Vb are equal in magnitude. Okay, so magnitude of Va is equal to magnitude of Vb. Well, let it be. So now if the box A is moving up and you are staying inside this box and watching C, otherwise you are staying at C watching A or B when box is moving down, right? So what may happen for the different values? Okay, so now I am going to explain you, how I read velocity of C, otherwise I call A. Okay, so velocity of A with respect to C, velocity of A with respect to C. So C is here, C is at rest. I assume C is at rest. Okay, so if C is at rest, then velocity of A with respect to C is equal to, it is moving up, right, box A is moving up and all upward direction are taken positive with velocity Va, right, velocity Va minus the velocity of C is 0. Okay, so velocity of C with respect to itself is 0. So I may put 0 here. So this will become what? So this is simply plus Va, right. So this is the value of velocity of A with respect to C, that is plus Va. Well, so now I am treating velocity of C with respect to A. Okay, it is just reverse. So what happens? So now I should write like this, velocity of C with respect to A. That means you are standing in A and watching C. If this is the situation, then this box which is at C is at rest. Its value is 0 minus velocity of A is upward. So it should be written plus, right? So plus Va. So that is equal to what I must write? I must write minus Va. This is the value of velocity of C with respect to A. Obviously, it looks somewhat funny, right? Because C is not in motion, definitely. But it is an illusion that happens for any observer who is there in A and watches C. Okay, so this is the case about velocity. And one more thing I have to tell you. So velocity of, right, B with respect to C, velocity of B with respect to C. So how I could write velocity of B with respect to C is equal to, so velocity of B with respect to C, B is coming down and all vectors downward take a negative, right. So minus Vb is the velocity of B with respect to ground minus the speed of velocity of C is 0. So definitely it is minus Vb. So this is the velocity of a B with respect to C, definitely it is right. Okay. So velocity of C with respect to B, right. So velocity of C with respect to B, how it should be written? Velocity of C with respect to B is equal to velocity of C is 0 minus velocity of B is downward, it is minus Vb. So this is equal to what may happen? It is plus Vb. So this is the value of velocity of C with respect to B. Okay. So then what it may happen for the other two, that is velocity of A with respect to B, velocity of A with respect to B. Okay. So these two are here. That should be written like this, velocity of A with respect to B is velocity of A with respect to ground is upward and upward is positive. So plus Va minus velocity of B downward, so it is a minus Vb. So this is equal to what I must write? I must write plus Va, right, it is plus Vb. Otherwise I simply write plus Va plus Vb inside bracket. Okay. This will give certain meaning. So now velocity of B with respect to A, right. So velocity of B with respect to A, so that is written like this, velocity of B with respect to A, which is equals, so velocity of B is downward, that is minus Vb, right, which is downward, and minus velocity of A is upward, so it should be written plus Va. So this is equal to, further what I can write, minus Vb and minus Va, otherwise I simply write minus, it is Va plus Vb, right. So these are the things that you must know in the relative motion when the motions of these bodies are uniform. Okay, now I explain the second situation where the system of these boxes are accelerated. Here I am simply treating this box B is falling down and there is no friction. Okay, so there is no friction. At this moment this box A also moves up with the same acceleration, right. So now I should treat the system like this. How I am going to treat now is in the second situation where we are seeing accelerated boxes, right, boxes A and B. Okay, so with respect to ground they are accelerated. Now I am going to describe the situation like this. Here I am simply saying that acceleration of A with respect to C. Okay, so acceleration of A with respect to C, acceleration of A with respect to C is equals, what is the acceleration of A? As we are seeing, it is upward, that is g, right, and all upward are taken positive, so it is plus g is one thing, minus C is in rest, so it should be written 0, this will be plus g. This is how we get acceleration of the box A with respect to C. And in the second situation, it is a acceleration of C with respect to A. Okay, so acceleration of C with respect to A, that is equals, C is in rest, so we write 0 minus acceleration of A is plus g, right, it is moving up, so this is equals minus g. This is how we get acceleration of C with respect to A. And then it is a acceleration of, okay, so acceleration of B with respect to C, acceleration of B with respect to C. So B is coming down and the downward are taken negative. So it is minus G minus acceleration of C is 0. So definitely it is minus G. So then acceleration of C with respect to B, right. So it is acceleration of C with respect to B. This is equals acceleration of C is 0 minus acceleration of B is downward, it is minus G. So this is equals plus G. So this will be the acceleration of C with respect to B. Finally, we are having two different cases. So acceleration of A with respect to B. Acceleration of A with respect to B. So that can be written like this. Acceleration of A is positive, which is plus G, right, minus acceleration of B is negative, it is minus G. Definitely it is plus G, right, plus G. This will be is equals, right. So what it may happen, it will be plus 2G. Next, it is acceleration of B with respect to A. Okay, so acceleration of B with respect to A, that is equals acceleration of B is downward, it is minus G. Acceleration of A is upward, it is plus G. It will be minus G, and that is equals minus 2G. This is the situation finally we get about the acceleration of B with respect to A. So all these special cases are much important. A final case where we are treating the roof of this support itself is accelerated. Okay, see, the roof itself is accelerated. If that is the situation, let us learn what happens to the acceleration of one body with respect to the other body. Now what I have to treat is acceleration of A with respect to C. Okay, so acceleration of A with respect to C. Acceleration of A with respect to C can be written like this, because the body is, that is A, which is already accelerated with a value G, being further accelerated by a value A, right, by the value A. Then the total acceleration of A with respect to ground will be plus G. Okay, so plus A, this should be the case. This total will become the acceleration of A with respect to ground minus acceleration of C, which is 0. So definitely it will be simply plus G plus A. Okay, there are several cases you may come across. This is one of the example what I feel happy to give you. Well, so the next is acceleration of C with respect to A. So acceleration of C with respect to A is, right, acceleration of C with respect to A. C is not accelerated, it is 0, minus, so what should be the acceleration of A with respect to ground? This much we already written here, that is plus G plus A. So when I open this bracket, it simply becomes minus G plus A. This is the acceleration of C with respect to A. And then acceleration of B with respect to C. Okay, so acceleration of B with respect to C is equals, B is coming down, right, but it is moving up with an acceleration A. Let me give one more thing, the condition if it is, let we consider A, that is this acceleration is less than G. Okay, so this could be the situation. If we know this, so definitely what I can write, this will be, it is the acceleration of this B, that is G minus A. Okay, so this much value is downward and this much value is upward. that should be subtracted, then we get net downward acceleration. This is the net acceleration of B with respect to ground, alright, and minus the acceleration of C, that is 0, which is at rest. Further, what I can write? I can simply write minus G minus A. This will be the acceleration of B with respect to C. So now acceleration of C with respect to B. So acceleration of C with respect to B is equal to acceleration of C is 0 minus what I can write, acceleration of B is this one, the terms inside bracket. This is minus G minus A. So finally what I get, that is equal to it will be plus G minus A. Now acceleration of A, right, acceleration of A with respect to B, acceleration of A with respect to B. So that is equal to, see, acceleration of A is how much? Acceleration of A is this thing what we already have here. So that is plus G plus A minus what is acceleration of B? This much, it is downward. So what I must write? It is minus G minus A, right. So this is equal to, what I can write further, this is equal to, it is plus G plus A, right, plus G minus A. When I open this bracket, definitely it will be is equals, right, it is plus G plus A plus G minus A. It will show you a very important conclusion, that is the term A get cancelled. That means if two bodies simultaneously accelerate upward, okay, so you need not consider that A, the term A in your calculation, okay. So definitely the final answer would be, it is plus 2G. This is the acceleration of A with respect to B. So now you can guess acceleration of B with respect to A, okay. So acceleration of B with respect to A. So acceleration of B with respect to A is equals, what I may write, see, acceleration of B is already written here, otherwise here you may get, so that is minus G minus A minus acceleration of B is this much and acceleration of A is here what we have already, that is plus of G plus A. So I need to solve this again, minus G minus A minus G plus A. This is equal to minus G, right, plus A minus G, right, minus A. One more time I am saying the term A getting cancelled. That is once again because of the same rule. If two systems are accelerated simultaneously in the same direction, so definitely there is no need of considering the term for your further calculations. So this is equal to minus 2G. This will be the acceleration of B with respect to A, and that's all about the basic relative motion and the acceleration in such kind of cases.